Hello and welcome to this instructional video on CATIA prismatic machining. We've been working through operations on the second setup of the example part, and in the previous video we looked at setting up a pocketing operation. So let's go into that operation and just generate the tool paths. So these are the tool paths. If you recall, we didn't spend a lot of time looking at the approaches and retracts, so we'll be looking at that in this video. Now, one thing that one can notice by just looking at these tool paths is this yellow dashed line here, and this indicates the positioning of the tool from the end of the previous operation, which is the profiling operation, to the start of the pocketing operation. So if we rewind on the tool paths, we can actually see that that's that move. Now, just looking at that, that should show you or tell you that there's going to be an issue here, because the tool is going to run right through the wall of the part to get to the start of the pocketing operation. And that's evident when we do the full video replay. And I'm going to really speed this up. And you will see here in a second the tool run right through the part to get from the end of the profiling operation to the beginning of the pocketing operation. So the only way to fix this, or the way to fix this actually, is by going back to the profiling operation and changing where the tool ends that operation. So this is one example where a problem in an operation is actually due to something that was not properly set in the previous operation. So let's hit OK. Let's hit OK here. And let's go back to the profiling operation. And what we want to look at here is, where does the tool end? And here are the tool paths. Let's hit OK here actually, and let's go to the last tab. Let's look at the final retract. So the final retract says that the tool comes off the part and then it lifts up 75 thousandths. Now the tool is going to end pretty much at this level, so 75 thousandths is just barely above, and then the tool shoots off and repositions to the pocketing operation, running right through the part. So this is not adequate. What we're going to do is we're going to add an additional motion. So we're going to add an axial motion on top of that 75 thousandths, and we're going to add this upwards to a plane. We're going to use the top of the part, and we're going to offset that upwards 100 thousandths. So we're forcing the tool upwards to a plane that's safe before the tool repositions to the pocketing operation. It's a bit hard to see this here. Actually, you can see it. It's this actually blue move here. So this is the actual final retract. So the tool is now at a position that's clear for it to reposition. So if we hit OK here now and go from our profiling operation into our pocketing operation and generate our tool paths, we now see that that yellow dashed line is now moving above the top of the part and not from below as it was before. So we are eliminating that collision problem. So that's one thing you have to pay attention to, is that sometimes there can be issues in the previous operation that can impact problems, or cause problems in the operation that you're working at. Okay, so let's look at a few things now with regards to the so as you recall, we had set the initial approach and retract just up to a plane. One thing we need to pay attention to is, with a pocket, is there is no side approach into pockets. The only way you can get into material is from above for a closed pocket. So there are a couple of strategies that one typically uses to get into material. One of these is using a helical approach. So the tool doesn't go plunge directly into the material, it moves in along a helical trajectory. One can also use ramp moves too, and these are both grayed out here. So what I'm going to do is I'm going to start off by just removing the approach and retract. So let's delete the approach. And the retract, we can leave the retract as is because you don't really have the option, of course, and it doesn't make sense to do any type of helical motion away from an operation or from a pass. So let's start with the approach. Notice now that the previously grayed out helical motion is now available. So let's add this. And there are two parameters that define the helical approach. If you double click on the actual pigtail line, it puts up a definition window and it shows you that there's the helix radius. In this case, it's the default 0.394, and then the height of the helix. And then the helix angle, so the angle of approach, the angle of the helix, which determines sort of the glide path of the tool into the material. You can change the radius if you want. This is the default value in CATIA. The most important value here, though, is your helix height. So this is really your engagement depth or your approach depth, and you always want your approach depth to be greater than your depth of cut. So if you remember that we set our depth of cut for the pocket to 50 thousandths, let's go ahead here then and set this to be slightly larger at 75 thousandths. So what this means is that the tool actually, if it's in a rapid mode, it actually breaks at 75 thousandths above where the tool is going to be cutting. And because the depth of cut is only 50 thousandths, that is above where the surface of the material is, 25 thousandths above. You can also, if you're not happy with this value here, if you want to round it off, you can go ahead and do this, but you'll be doing this over and over again. I will just set it to half an inch, and we leave the helix angle as is. So that's our helical approach. Let's hit OK. And let's go ahead and generate this just to see what it looks like before we do much more. Because we'd like to get this correct before we start adding it to other approaches and retracts. So let's generate our toolpath, and let's go ahead and rewind. And let's go ahead and go into point-by-point replay, and let's step through. So what we're seeing here now in the yellow is that helical lead-in, and then it switches over to green. So if I go to a side view, you can see what I was saying earlier on, that if we look at the height of this helical move, that's the distance from this point here to this, it hits material. This is where it first hits material. So that's 25 thousandths there, and then this is our depth of cut, 50 thousandths. So the tool is actually starting to move on the approach feed rate before it hits the material, which is always what you want. So again, keep your approach depth, regardless of whether it's an axial or helical or ramp, greater than your depth of cut. So that's set up well. And then if we go to plane by plane, this is the end of the path here where the tool is, and then we see our retract move, and then a rapid over to beginning the approach for the next level. And this tells us that we have to also go about setting the approach for the return or approach between levels. So let's hit OK here. And let's go ahead and look at our return between levels, approach and retract. So again, there's nothing set right now, so the tool repositions whatever CATIA is using as its default. We want to control how the tool drops down as it gets deeper and deeper into the part. So we're going to go ahead and we're going to activate, so right-click, activate. And for our return between levels, once you've machined a level, you are also, as you go deeper in, you're plunging into the material to machine the level below it. So we want to use the same helical approach strategy that we used previously for the initial approach. So let's add this. And again, if we double click on the squiggly line, or you can double click on each value to set them separately, we can set our radius to 0.5 and our helical depth again to 75 thousandths to ensure that we are stopping before we hit the material, however we're going. So that's our approach. Our retract, so for our retract, once we're done with the level, we can retract the tool back up the same distance that we have come down on the helix. So in this case, there's no helical retract. We can just lift the tool directly upwards, and we can set this to 75 thousandths too. So let's go ahead and generate. our toolpaths and see what is different or what has been added. So we're still in plane by plane. Let's rewind this to the beginning. Let's step through. For some reason, CATIA, when you use plane by plane, it displays the approach as a gray line, but this is really a helix. It should be yellow. It's not a line actually, it's a helix. So this is our first approach, our toolpath. This is where the tool ends. So we see the retract that we set. We set it at 75 thousandths. So the tool lifts up, obviously it's clear of the material, rapids over, and it rapids downwards a distance of 50 thousandths, and then it engages the helical approach for the next level. So now we see this helical approach, and the tool is down now at the next level below, which is 100 thousandths, 50 plus 50, and it executes the toolpath, lifts up, and so on. So we have, by adding that helical approach, what we're doing is we're gradually bringing the tool into the material. We're avoiding a direct plunge, which is always harder on the tool. It's a move-in that has X and Y motion to it too, not just the Z. And we're ensuring that the tools, this rapid move here, we're ensuring that that rapid move stops before the tool, 25 thousandths before the tool enters the material. So let us hit OK here and look at our macros to see if there's anything else that's important to set. So looking at this, we'll see that here that we have, of course, a finishing pass, if I recall correctly. So we need to be concerned about this and figure out how to get the tool into that finishing pass. So let's go ahead and do this. Let's go ahead first of all and activate our approach and retract for the finishing pass. Let's just use a helical approach for our finishing. So let's go ahead and do this here. Actually, you know what, on second thought, what I'm going to do, let's just delete this. I'm actually going to bring the tool in on a circular motion into contact with the wall. So let's actually start with a circular motion in, and then let's add a helical move to bring the tool to that circular motion. So we have a helical move, which will bring the tool to the correct depth, and then using a circular lead in, the tool will move into that finishing pass. So let's go ahead and double click on the helix and just set it to what we've been using, which is 1/2 inch and 75 thousandths. And then for the retract, let's again use a circular lead out, and then let's go ahead and have an axial move upwards. Let's have this at 100 thousandths. So let's see what this does for us, and we can always go back and change things if it doesn't look correct. So let's generate our toolpaths. So we can see here already, this here is the helical move on the approach. Actually, let's rewind this. Let's go forward and back up. So this is going forward, takes us all the way to the end, and then backing up gets back to the last motion, which is the finishing operation, which is the light blue toolpath. So this is the circular lead-in that I added. So the tool is going to come in on this circle and then engage along the blue toolpath for the finishing pass. If I back up one more step, I should see the helix here. So this is the 0.75 thousandths depth helix that brings the tool from above the part to the correct cutting depth. And then this is the repositioning from the end of the toolpath. So if we back up one more, we'll see this is the last roughing pass on the bottom. This looks a bit strange here, this blue move. I would have expected this to be on the blue toolpath. For some reason it's on, it's still a bit strange here, what's going on here. This is something not expected. So if we back up forward, This here is the retract move. I was actually expecting that to be here. This looks like the final retract because again the finishing operation is the finishing operation is the last step in this pocket. So maybe to fix this issue, which again I'm not sure why this is here, it should be at the end of the light blue. Let's go ahead and to fix this, let's go ahead for the return, finish, pass, retract. Let's just delete these. And then for our final retract, instead of dragging the tool or rapiding the tool or moving it up at the retract rate right against the wall, let's move the tool off. So let's delete this tool pad, the plane, and let's have a circular lead out before we lift the tool all the way up to the plane. So let's go ahead and select the top of the part as our retract plane. So the tool at the end of the finishing tool pass will come off using a circular lead out and then lift up to the retract plane. Let's see if that cleans things up a bit. Again, I'm not sure why that was happening. It's not what I was expecting, but let's see what happens here now. So let's these are the tool paths. Let's back up one. So this here shows you that that actually worked. So here's the lead in where the tool moves in on yellow, then it runs around, does the finishing pass. When it comes back around, this here now is the final retract. So it's doing a circular lead out, and then it's doing a retract move all the way up to this plane here. So again, the tool is not retracting in contact with the wall, which can cause scratch marks because the tool may bounce against the wall as it's been pulled upwards. So let's see our tool paths again. So again, it's not clear to me why that return in a level, so that return, finish, pass, retract caused that issue, but I was able to fix it by adding that circular lead out onto the retract move. As far as these other options go, we are not doing any repositioning on the level. We're not doing any linking. We're not too concerned about clearance since we're controlling that using these approaches and retracts, and there are no fixtures in the area to be concerned about. So again, in summary, this here let's go ahead actually and rerun our tool paths one last time, and let's go into our material removal just to make sure that we haven't missed anything, because if you remember, one of the issues we had previously was that the cutter was running through the wall of the part at the end of the profiling operation. Let's switch our replay mode to continuous replay, and let's go ahead and run. There you go. That collision has been removed. Actually, let's back it up. Let's slow it down a little bit on the pocketing just so that we can see maybe some of those, we can catch. Actually, it might be hard to catch that helical lead in. Yeah, it's a bit difficult to do. But again, you can see, of course, that problem has been removed. That was one of the issues. And with the helical lead-ins, the tool has been gradually brought to depth rather than plunging directly down into the material. So again, those are the ways to set up your retracts and approaches. One way of setting up retracts and approaches for a closed pocket where you don't have the option to bring the tool in from the side, you have to bring the tool directly into the material from above.